future value, as it says here, it's just the point at some future point in time relative to the reference point. So here we have time 0, which is our reference point, and here we have time t, which is this point in the future. And we have a given amount of money today, which we're calling C0 here, and its future value here is basically how much it'll be as a result of growing from compounding. So you've got this money here, and it compounds for 1, 2, 3, all the way out here for t periods. And how much, if you had this, how much would you have out here? The equation on this is one of the more central ones in finance. The future value at time t, how much would you have at time t? C0, how much you have at 0, times 1 plus r. 1 plus r, the 1 captures the fact that at the end of the period you still have what you started with. R captures the return, the interest rate of the return at which the money compounds. And t captures the number of periods over which it compounds. And notice that it's not multiplied, but it's actually an exponent because it's 1 plus r times 1 plus r times 1 plus r plus times 1 plus r for t times. It captures the compounding. It captures the interest on the interest, the returns on the returns. So here's an example. You've got $100 and you can earn 6% per year. How much do you have in 1 year? You start with 100 times 1 plus r, 1.06 to the first. You'll have $106. How about after 2 years? We've looked at this problem where we said, okay, after 1 year we'd have $106. Then 6% of $106 is 636. So let's add it back to 106 and we get 112.36. Notice we can do it all in one step. You have 100 times 1.06 squared, which really reflects 100 times 1.06, which is how much you'd have after 1 year, times 1.06, which is how much you'd have after 2 years, and it'd be 112.36. 3 years, 119.10. Again, 100 grows by 1.06 after 1 year, times 1.06 after 2 years, times 1.06 after 3 years, 119.10. And after 20 years, it's just 1.06 times 1.06 times 1.06 20 times, and your $100 will more than triple after 20 years. And it's a lot easier doing it this way using the formula than it would be to say, okay, after 1 year we'd have 106, then let's figure out 6% of that and add that so we know how much we'd have after 2 years. Let's figure 6% of that, add it to what we had after 2 years to figure out what we had at 3. It's a lot easier to simply use this nice convenient expression which captures all that than to have to do all the steps. So let's take a look at a basic problem. So Martha is going to invest $500 a day in an account that's 9% per year in compound interest. How much should she have in 12 years? Well, she has C0 today, and it's going to compound by R. It's going to do that for 12 years. So after 1 year, she'd have C0 times 1 plus R. After 2 years, C0 times 1 plus R times 1 plus R. So in this case, she has 500. Every year, she's going to get 9% interest, and that's going to happen for 12 years. And if you work that out on your calculator as 500 times 1.09 to the 12th, you wind up with $1,406.33. So the money almost triples over 12 years when the interest rate is 9%.